Hi, this is Ashutosh and welcome once again in this course of indefinite integrals. So far we have covered almost every sub technique of substitution, and in this lesson we are going to do a transformation and substitution both. Means in some integrand we can see that any of this technique will not work, means individually transformation will not work, and individually a substitution will not work. So we have to apply both of them. The sequence of applying transformation and substitution is not sure that first of all we have to do transformation, or substitution is not guaranteed to be said. But you can see that in some of the integrand, it depends upon actually the nature of integrand. So in some of the integrand, transformation will be done first and then substitution, or vice versa. So let us try to understand what kind of transformation and substitution we have to do there. So the first example I have taken, which is in the form of linear 1 over linear 2 the whole square root, or you can say the square root of linear 1 over square root of linear 2. So whenever you see that this kind of integrand anywhere, we have to do this transformation first. So the transformation is what? We have to rationalize the numerator and then integrate. So this is the guideline, or you can say this is the slogan whenever you see this kind of integrand. So for this, what we can do, we are going to rationalize the numerator. So for that we have to take the square root of x plus 2 to multiply and divide, and so in the denominator we will get the square root of 2x minus 1 times x plus 2, and the numerator will be x plus 2 now. So we can see now 2x minus 1 times x plus 2 can be expanded, and then we can write a quadratic like 2x squared plus 3x minus 2. And now this is actually going to be in the form of px plus q divided by square root of ax squared plus bx plus c. So you can easily understand that this can be done by the process of splitting into 2, which we have discussed in lesson number 15. So the basic idea of this transformation is to transform the given into integrand in the integrand from where we can apply the split into 2 technique of substitution. So let us do it further. So of course this is x plus 2 and divided by square root of 2x squared plus 3x minus 2. So in splitting into 2 method, what we can do, we have to simply write the numerator in the in terms of the derivative of derivative of quadratic. So first of all, I have written the derivative of quadratic here, and of course one of the technique is to find the derivative, write the numerator in term of derivative of quadratic is like this thing, lambda times x squared plus 3x minus 2 derivative plus mu, and then you find lambda and mu from there. But I suggest you to go by this method. First of all, write the derivative of this quadratic. So this is 4x plus 3, and now try to make this 4x plus 3 x plus 2. So for that, of course, the coefficient of x here is 1, so we have to divide the whole expression with 4, and since we are getting 3 by 4 an extra term, so we should subtract it to compensate, and finally we have to add 2 because this x plus 2 expression is containing that number. So after manipulation, after simplification, this will be 5 by 4 here, the constant, and after splitting into 2, you can see that this integrand can be handled by direct substitution, and this can be handled by completing the square method in applying the special line, one of the special line. So it can be done, and I am not going to do. So the students are requested to do the rest of the parts of this question. Now let's apply the similar technique in this. Sometimes you will find this kind of integrand in which first substitution will occur. Now you can see here why I have said that transformation and substitution both, because you can see that first of all we have to transform, and now here in I1 you are applying the substitution, and here it can be also said that you are applying a substitution process in disguised manner. So this is transformation and substitution. Here also you can see that first of all you are substituting t is equal to sine x, and then you are transforming it because this will become now root over 3 minus t. So again it will be root over linear over divided by root over linear. So this is actually first the substitution is done, then transformation, and then again after just splitting into 2 you are going to do the substitution. So there's a combination of substitution, transformation, substitution. So that is why this kind of integrand can be categorized as the transformation and substitution process. So I think the students are able to find the integration further. Now the second kind of integrand in which this transformation and substitution will happen simultaneously or one by one is this one. 1 over, you can see that integrand may be in the form of 1 over a sine square x plus minus b cos square x, or 1 over a sine x plus b cos x the whole square, or 1 over c plus a sine square x plus b cos square x, or 1 over a plus minus b sine square x, or 1 over b a plus minus b cos square x. So you can see in all of this type you can easily observe that there is a sine square x or cos square x or both. So whenever this kind of integrand you see, we have to divide the numerator and denominator with cos square x, and then we have to proceed. So let us try to understand this thing with an example. So suppose I have the integrand as 1 over 2 sine square x plus 3 cos square x. So of course we are going to divide the numerator and denominator with cos square x. So at the top you will get 1 over cos square x, and in the bottom, that means in denominator, you will get 2 sine square x plus 3 cos square x by cos square x. So of course this 1 over cos square x will become sec square x, and here when you split this will become 2 tan square x plus 3. So why we are making dividing this with the cos square x? Now you can easily guess that when you divide the numerator you will get sec square x in the top, and in the denominator you will get 1 tan, at least 1 tan you will get. So this tan x can be substituted. So this t is equal to tan x now, and so dt will be sec square x dx, and so the integrand can be written in the form of t as 1 over 2t square plus 3, and from there you can take this 2 out because I want to make the leading coefficient of this quadratic in the denominator as 1. So this will become t square plus 3 by 2, and of course it can be written as 1 over t square plus root 3 by 2 the whole square, so that I can simply see the integrand form of this, and you can use here this one of the special line, and of course this has the formula 1 over a tan inverse x by a plus c, and so that I have used that thing here. So this is 1 over a, that is root 3 by 2 tan inverse 2t by root 3, and after the final step we can simply substitute t is equal to tan x. That was our original substitution during the process. So so this is the technique, or this is the method we can apply to integrate such kind of integrations or integrals. Sorry. And now let's do one other example. Here I have written the integrand as 1 over 2 sin x plus 3 cos x the whole square, and how can we do? We can simply because it is again in the form of this one, so here we have to again divide with cos square x. So in the numerator you can guess it will be sec square x, because we are going to make this sec square x deliberately. This is our intention of dividing this cos square x. So that is why the sec square x will appear in the top always, and in the denominator you can just divide with cos square x. So of course this is already a perfect square, So in this parenthesis you will get cos x only divided, should be divided into this two parts. So this is what 2 sin x over cos x, and this 3 cos x by cos x will be 1. So this 2 sin x by cos x can be written as 2 tan x, and of course in the denominator you will have 1 tan x at least, as I said before also. So this tan x can be substituted for t, but you can see that this 2 tan x plus 3 is entire function which has only tan x and other things are constant. So these constants can be adjusted, and so you can substitute it as a whole. So t is equal to 2 tan x plus 3 is t, and of course this tt will be 2 sec square x. And further, if I want to write this, it will become dt over t square, and it is very easy to do the process now. I think there will be 1 over 2 also. Alright, so after that the students are familiar with the steps, and they can do it easily. Let us do this example, and how can we just transform this first into one of the required integrand, and from there we can proceed. So suppose I have cos x over cos 3x. So you know this cos 3x has the formula or the identity as 4 cos cube x minus 3 cos x, and after that you can cancel 1 cos x by taking this cos x as a common, and you will have 4 cos square x minus 3 in the denominator. Now this will become the main integrand from where we have to proceed. So this is one of the integrand form we are looking for, and we can divide this whole expression with cos square x in denominator and numerator as well. So in numerator you will have sec square x, and in the denominator we will have 4 minus 3 sec square x. But now you can see we are not getting any tan here, but of course we can get, because sec square x can be written as 1 plus tan square x, and this tan x can be now substituted for t. So of course this will, after simplification, you can get sec square x over 1 minus 3 tan square x, and so t is equal to tan x, and dt will be now sec square x dx, and so on. So this kind of questions can be handled in this way. So that's all for the first part of the substitution and transformation both. In next lesson we are going to do the second part of this similar technique, but some other kind of functions we are going to deal with. So that's all for today's lesson. Thank you very much.